हेलो भाई लोग, कैसे हो आप सारे? बढ़िया ही होंगे। आ चुके हैं ऑर्डर सेट के एक और वीडियो में। पिछली वीडियो में देखा था कि मिंजी डब्ल्यू के फाइल्स में कौन कौन से चेंजेस करने हैं हमें। उसकी पहले वाली वीडियो में देखा था कि ऑर्डर सेट क्या है, पॉलिसी बेस्ड डेटा स्ट्रक्चर क्यों कहलाता है, इसके दो एडिशनल फंक्शनलिटीज जो है फाइंड बाय ऑर्डर, ऑर्डर ऑफ की वगैरह सब देखा था। मतलब जितनी चीज़ें हमें ऑर्डर सेट के बारे में जाननी है वो सब देखा था। और इस वीडियो में हम लोग देखेंगे कि ऑर्डर सेट को हम कोड में कैसे इंप्लीमेंट करते हैं, बिकॉज एज आई हैव ऑल्सो टोल्ड इन द प्रीवियस वीडियोज एज वेल. Understanding the concept is important, but writing that particular concept into the code is more important. So in this video we are going to focus on the most important part, which is writing the code. So uh, uh, PBDS is not defined in the header file stdc++.h. For that, for PBDS we have to include another two HPP files that are written here. I will be also writing the code in the comment section as well. So guys, so that you guys can copy it directly rather than writing it. Namespace we generally write std, but for PBDS we have to also write it like this. And this one is basically a type def structure which defines a particular tree data structure. And here I have given the name as ordered set, ORD set. You can give any name, but what does this particular line mean? What does this each and every keyword or jargon that is it is written here, for example null type, less int, reflectory, what all this particular technical terms mean. For that we have to move for the use blackboard. So this is the line. Here we are type def means we are defining it as a shortcut, means all this term will be represented by this single keyword, this ordered set. Okay, so what does this first term mean, which is int? It defines the data type we want to store. Data type that we want to store. For example, if you are willing to store characters in ordered set, then you have to write string instead of integer. Okay. Next one is null type. Now it is basically that means this particular space is used for any comparator function, inbuilt comparator function that are present. But here we are not willing to write any comparator function or use any kind of comparator function. So we are just writing null type, which is not using any kind of comparator function. It is null in this case. Next one is less int. It specifies that we want to store data in ascending order. Ascending order. If you want to store data in descending order, means in reverse form of the sorted manner, you can also write greater in this place. We will modify this thing in the code. Next one is arbitrary tag. Now, as I told you, ordered set is a policy based data structure. So arbitrary tag means it will use red flag tree in backend to implement. Rather than arbitrary tag, we can also use order vector tree, etc. There are multiple trees as well. But as far as competitive programming is concerned, as far as ICPC means it is a standard competition of competitive programming. There only arbitrary tag is allowed from their side. So we are not much into learning, or there are not enough resources as well on internet to include another type of tree as well. No worries, we are not, that is not needed in this case. And the fourth one is tree order statistics node update. Now the two functionalities that are signature of or USP of ordered set, which are find by order and order by key, they are due to this particular line that we are including here. It enables uh, to store additional information in tree, such as some statistical information, such as subtrees information, their metadata and all that, which enables ordered set to implement functionality such as which element is the means kth largest element, means we are finding that all the smaller elements from a particular value x in ordered set. So all these functionalities are implemented by this particular line, that is tree order statistics node update. Now, update means update return here specifies that after modifying the tree, means after deletion and all that, it will enable in the tree backend, in the tree which is in the backend, to update the nodes. If you don't write this update, if you erase this update and underscore, the tree that will be forming won't be modifiable, or it will be only like read form. You won't be able to make any deletion operation and insertion operation and all that. So this update function enables it to modify it. So this was all about this particular line. Now let us move directly to the implementation part. Okay, let us create ordered set named small a. Okay, here ordered set you can give any name that you want. It is a type def or it's a short form for this particular line. Okay, no worries. Here we are writing the name a. Now insertion is as per the normal set only. A dot insert 1. Now we will insert a dot insert 2. Let us insert 1 multiple times. 3, 4, 5, 6. Okay, these are the insertions that we did. Now you want a dot size. Okay, let us run the code. A dot size is 6. Instead of inserting 1 multiple times, okay, let us insert 1 here also one more time. And also a dot size will be only 6, because as I told you, also implements the functionality of storing unique elements only. Okay, no worries. Now see out another functionality, which is a dot order underscore of underscore key, means it will return how many elements are there which are strictly lesser than particular element that we are entering. For example, we are writing 5. So how many elements are there which are less than 5? 1, 2, 3, 4. 4 elements. So answer should be 4 in this case. Yes, as you can see, answer is 4 in this case. Now another functionality, see out find underscore by underscore order, or let us try to find that which element is stored at the fourth index. Okay, but as I told you, it returns the iterator. So to have the value, we have to write star here. Here let us write handle, so that output is there in two separate lines. Find by order 4. What's the error? Find. Okay, we have to write here name a dot find by order. Okay, as you can see, 5. So how many elements? Means fourth is stored on which index? Means which element is stored on the fourth index? That is 5, because it follows 0 based indexing, 0, 1, 2, 3, 4. So on the fourth index, no, it follows 1 based indexing. So on the fourth index, 1, 2, 3, 4, and 5. 5 is stored. Okay. So this is all about ordered set. As I told you, if we write greater here, it will store data in descending order. So for auto IT A, cout IT. Now if we run the code, see, it is having descending order 6, 5, 4, 3, 2, 1. And now if less, it will be 1, 2, 3, 4, 5, 6. Okay. So guys, this was all about ordered set. These are the main two functionalities which makes ordered set very useful. And I will also write this code in the comments, so that comment section, so you guys can immediately copy this header files and all that. But before including this, please make sure that you guys have modified all the files that we have understood in the previous video, to make changes in that .imp file, .hpp file, to remove that particular digit part. And I think it's enough for the audit set. We'll meet in the next video. And yeah, I forget to mention this thing in the previous two videos. I will be attaching one Code Forces blog link as well into the comment section. I will attach that link in all the three videos, because those who have watched the first two videos and they are not coming for the third video, then they should also be aware about the blog of Code Forces. That blog contains all the necessary information that one needs to know about audit sets. So I will be also attaching that link as well in the comment section, so you guys can also check it out. So till then, we will meet in the next video. Till then, keep learning, keep hardworking. Thank you.